So what are the geometries you can use in the standard geometries for the rectangular modules? It's those boundaries. You can select a length A and a length B, which helps you provide you with all the data you need for the balcony. And you can select some overhangs on the left and on the right, as you can see highlighted here in red. If you want to do so, you can select to use some sort of supports, external supports, which have fixed positions, as you can see here. Of course, you can deselect all these supports to only use some of them or none of them. And I will go on with the loggia. It's quite the same. So you have two different lengths, length A and length B. You can select an overhang here, and of course supports. Again, for the inner corner, again, in this case, it's two lengths as well, length A, length B, with the overhangs left and right and the supports, which you can choose to use. And for the outer corner, you have to select 4 different lengths, A, B, C, and D. And you can use, again, different support locations if you want to do so. So let's start and have a look into the software again and start with the standard geometry input parameters. So as I said, you have the 4 different geometries. On the left side, again, you choose all your inputs. And on the right side, you have the top view and the side view for your selected connection line. So all the input data is done in the left side window. And yeah, as you can see here, in this case, rectangular shape, we only had 1 connection line, but it depends on the standard geometry you have chosen. We start with the rectangular geometry. We don't use the freeform so far. We can select here our length A, and as you can see here, we validate the data, so you aren't able to use any data that isn't possible with our product in this case. You choose to do an overhang, deselect it, or you can, as I said, use supports. You can click on the supports to deselect them if you don't want to use those supports. In this case, we leave that 1 support here. Then you have to choose between different connection types, slab to slab, or if inside you only have a wall to the up or to the down side, you can select those connection types as well. If you have any sort of height offset, you can do that here as well. So you have to select the different thickness of the inside floor. And you can choose here the height offset, same as in the expansion joint module here. Of course, you have to select the width of the wall or the downside beam here as well. In this case, yeah, we leave it with 200 without any sort of height offset. After that, you can enter your connection line properties. In this case, we only have 1 connection line. But if you have any more connection lines, you have to select the connection line in the Dropbox here. Next information you can do is you can select sections where you don't want to have any sort of load capacity for the isocorp elements. For instance, if you have any sort of holes in your floor which will collide with our bars, you can select those elements, choose the spacing and the length of those sections. In this case, we position our isocorp type Z elements here, which is some sort of insulation without any sort of load capacity. Then after that, you select the material, the concrete grade for the floor or slab, and the structural behavior. As I said, you can choose in the standard geometry to use the automatic structural behavior, which will take into account the placement of our support, which make it easier for you to decide whether it's necessary to have some sort of bending moment. Of course, you can also select free type set, but in this case, it will change and make an error because you won't have any sort of connection here in this case. After that, you can select the concrete cover for our elements, the element height, and you can choose if this connection line has some sort of alternative type of connection. So if you have more than one connection line, you can choose if some of those connection lines are only wall connections or if all of them are slab-to-slab connections. Then after that, you can choose the maximum utilization for the static proofs. Default value here is 90%, but of course you can go up to 100% here. Or you can choose if you want to increase or decrease the amount of different isocorp elements which should be positioned. I would start with automatic, which will make you the most economic solution. Isocorp model, of course, is necessary. And the toggle button here is for prefabricated elements. And the last input here is the concrete grade for the balcony slab. Then we go on with the load tab. For the standard geometries, it's quite simple. We provide you with different default values. Of course, the dead load of the concrete is calculated automatically. You can select different loads, constant loads for your finishes. You can select the edge load, so some sort of railings or parapet loads here. You can select if your railing is only in the front of the balcony or if it goes around the whole geometry. Your live loads, you can select if you have to use any sort of edge moment, so persons pushing against the railing, or if you have any sort of masonry or other line loads which are parallel to the connection line. You can choose the distance to that connection line and the load value here as well. But we go on with 0 for this. All the loads we've entered here are vertical loads. After that, you can choose to enter horizontal loads in two different directions, in the X and Y direction. If you have any sort of wind loads, for example, you can do so, or you can also automatically calculate earthquake loads here, which will be then calculated by Eurocode. The manual product installation part, we'll skip that part for the moment. We'll come back to that later. So that's all the information we need to do a calculation in the next step as well. So, of course, we start the calculation in the next step. Then we can check our element placement on the results page. We can check, of course, our connection lines and especially our design loads, the shear forces and bending moments across all the connection lines. On the result page, we can check for errors and warnings, and we can manual swap isocorp elements, element by element or position by position. But we have a look at that as well. And of course, you can also export a log file as a PDF file here as well. So we start by pressing the calculate button again. Takes some seconds for our FE solver to do the magic, and we are on the result page. You can swap again to the input page if you have to do any changes to your system. The first part here is the top view again with the positioning of the elements, and to the right side you have the position list with all the isocorp that are selected here. So the red color means those are elements which only provide shear force transmission, and the blue elements provide you with moment, bending moment, and shear force. So as you can see on the left side, opposite to the support, it's only necessary to use shear force transmission here. If we go down here, we can choose our connection line. In this case, we only have one connection line, one design combination. We can check the bending moment here across our calculation, and it's calculated or located from node 3 to node 4. So in this case, node 3 is on the left side of the of the curve, node force on the right side. So again, across the support, we don't need any shear forces, so we don't have any bending moment here, and the shear forces change directions. Across that or under that, we have all the different static proofs for all the positions. In this case, we have 4 different elements selected. We have all the utilizations for bending moments and for the shear forces. And of course, you can check the stats here as well. In this case, it's all green, it's all fine. All the static proofs are under 100%, or in this case, under 90%, which was our maximum utilization chosen. Here, you can swap elements to use any different load stage if you want to do so in the process, and recalculate all the static proofs in this case. As you can see, you can do it right up there as well for all the positionings, in this case for number 2. We chosen the same load case with then in position number 1 and for position 2 as well. So we are left with 2 different element types in this instance, which might make it easier on the construction side, but of course isn't the most economical solution if you have to look at that. Here as well, you can have a look at all the information and all the warnings which will provide you here. Warnings aren't errors, so they provide you with additional information you might have to look up into your construction phase. So in this case, we manipulate our system, we delete our support, and the cantilever length is now 4 meters, which means, okay, our product range couldn't provide any sort of product for that because the load is too high. In this case, you can send the project file directly to Schöck, maybe to make our department, our structural design department, provide you with a special isocorp element. But of course, as highlighted here, we have some errors, and we can double check which the problem is. In this case, as you can see here, the utilization is above 100% for the bending moments. So we can provide you with a solution here with our standard products. And of course, as I said, you can export a log file, a PDF file as well. We do so by clicking on the export log, takes some seconds again, and after that you have in this case, we exported a file with some errors, which will be clearly highlighted here as a watermark. So if we want to show it to some other engineer or some other responsible person in your project, you can provide those data as well, but it's clearly highlighted that there are some errors and the system isn't statically correct. At the end, we also provide you with some additional information about building physics, and yeah, so more or less all the information you need. So we go on. We've seen the geometric data we can select for the standard geometries, and we go on with the freeform geometries and with the input data that you can choose here. So at first, if you enter the mode, the freeform mode, you enter the freeform toggle button. All the geometric data which you have already selected in your standard geometry will be transferred. But you have, of course, different additional functions available via a toolbar in the software itself. We have a look at that, of course. All the node coordinates can be entered with millimeter precision here in tables, especially. And of course, you can add any additional connection lines, support walls, point loads, line loads, and place them wherever you want to do so. So we start with the standard geometry. In this case, it's the inner corner, as you can see, and choose to select the freeform. And we get additional information that you're swapping to the freeform mode, and you can do so, or you can cancel the process here. And now we are in the freeform mode. As you can see, we have two different connection lines. We have all the node coordinates in this case in table form. So you can, of course, change those coordinates here as well. But we have a look at the connection lines, connection line 1 and 2 in this case, and the structural behavior. Yeah, you can't choose the automatical solution here. So you have to choose if you have bending moment and shear forces, or if you only want to provide products with shear forces. You also see here the toolbar. With the select tool, you can move nodes, but you can also do that by typing in the coordinates in the table as well. Or you can do so by typing here the length of the connection line 2, in this case, leaning on from node number 4, 1.8 meters. And yeah, you can deselect it. You can make the changes again in the table form, or you can move the node again to come back to your default geometry. Of course, you can also move other nodes. In this case, node number 2, for instance. We can add nodes to our system, maybe inside of some outer lines or inside of our structure itself. And after that, you can move those nodes by table, or as we can see here, by the select tool. Next step maybe you want to do is to add a support. In this case, a punctual support. You can choose to do so wherever you want, or you can choose to have some line support, some walls. And if you add a new support, you can choose to have it infinitive stiff, or you can enter the stiffness value for the support itself. Of course, you can also do that by clicking on the line support, which will provide you with a wall, where you can also choose the stiffness value if you want to do so. In this case, we delete those information. We don't want to use the line support or the punctual support, but we want to have another line here and add the wall on this line. Maybe you can do so as well. It doesn't have to be the outside lines where you can place your line loads or your line supports. Okay, so we finalize our module here. We can also add additional connection lines with isocorp elements. In this case, we had some loads here, which will be automatically deleted if we choose to have a connection line on this line here. And as you can see, you can also add the properties here and make some final changes to your system. Okay, so that's all you can do with the different geometry data, but also you can have different load cases in the freeform geometry. You can have any number of load cases. You can add additional line loads and point loads wherever you want, and you have the possibility to add customized design combinations, which also will affect, of course, the static proofs for our isocorp elements. So let's have a look at that as well. We still are in the freeform geometry. We have a line support here. We'll go down to our load part here. As you can see, it looks quite different than in the standard geometry. You have the different characteristic load assumptions, which will be automatically transferred from the standard geometry. The dead loads, the distribution loaded, which is also deselected, so you can change that, but the finishes can be changed here in this case, or if you click on the graphic interface as well. We can go on with the edge loads for the railing. You can of course, change it here in the table or in the graphic interface as well. So if you want to have different railing loads per line, you can do so by selecting it in the graphic interface, or as I said, also in the table here. You can add, of course, new loads. For instance, if you want to use any type of snow loads, you can do so and select if it's permanent, variable, or the accidental load by the Euro code. This case, snow distributed load. I select 2 kilonewton per square meter here, and as you can see, it's automatically selected in the design combination for the ultimate limit state. We also have a serviceability limit state here, which provides you with the calculation for the deflection and the characteristic levels. For the ULS, snow is already selected. You can choose your partial safety factors and your combination factors regarding the Eurocode calculations. In this case, we add another design combination without snow deselected. So in this case, snow won't affect the load calculations here. Of course, you can also add any type of support loads if you want to do so. So we can have a look at different point loads, for example. Support loads from the upper floor, which will be transferred in our balcony geometry. In this case, we add another node here. We select it and place it in our geometry and add the point load symbol here. Just click the button and add your loads wherever you want. And it's automatically selected here in the ULS in all the new design combinations. So you have to unchoose it so you won't make any errors. And line loads as well, you can choose where you want to have those in your geometry as well. Okay, so let's finish our look into the isocorp module by having a look at the manual structural behavior. That's a feature which will provide you in the standard geometry and in the freeform geometry. It makes it possible to position your isocorp element very flexible wherever you want to do so. And you can also select the structural behavior of the different isocorp elements and the structural behavior. So a combination of shear and bending moments. Isocorp elements may also vary inside of one connection line here as well. 3 areas where you don't have chosen any sort of structural behavior were automatically filled with our type Z insulation elements. So let's have a look at that. Here as you can see, we are in the standard geometry. We have a supported balcony with one support on the left side here, only one connection line. We choose to have the structural behavior of manual. At first, we don't have placed any sort of isocorp element, and the validation shows that there's an error. Of course, we have to make some sort of connection, otherwise it won't work. In this case, so you can choose to have different sort of linear connections. For our 1 meter elements, you can choose to have the whole element placed or half the elements. For our QP elements, the punctual elements, you can have the different lengths. In this case, we select to choose one type QP element with 500 millimeters right across the support. And we want to have one type K element, which provides bending moment as well, with 1 meter, and 2 other type K elements, half elements with 500 millimeters are also placed here in the geometry. You can position it graphically here in the user interface, and to make it easier, you can select the type Z elements, in this case with 500 millimeters, so you can place it here very exact. In this case, I've made a free section of 500 millimeters to show you that this is filled up with our type Z elements as well. So we have 1, 2, 3 different type K elements and 1 type QP element, and 3 different sections of our type Z elements for our insulation elements. As you can see, position 2 and 3 are half elements with different load stages, so we can select to have the same load stage here, which will provide you with a much nicer, cleaner solution in this case. And with the manual structural behavior, it's possible for you to select if you want to have any sort of distribution load and to have any sort of spacing between different isocorp elements. So that's it for the module balcony. Let's have a final look at additional design software for the isocorp, which we will provide you as a download. I would say standard desktop software, which you can download at our Schöck.com website. So that's not a web-based software. It's a software you have to download and you have to update by yourself. But it provides you with 2 different features. One software provides you with the product range of our T and XT type SK and SQ elements. So those are the steel to concrete elements. As you can see down there, that's the software itself. It's a standard desktop application, which is running on all Windows PC. And the other option which will provide you for isocorp is, of course, our steel to steel elements, which is another software application. So you can choose to use all of them and download it by yourself on our website, Schöck.com. That's it. I'm done with my slides, with my presentation. I hope you've learned something about Scalix, and of course, I hope you try to use it in the future if you haven't done so far. Of course, we are always happy to get some feedback from our customers to use which really use our software and which will provide us with different ideas to make it even better in the future. Thank you for your attention.